Hey everybody, I am going to give you a little bit of a lesson. It's definitely should be a review lesson on simplifying radicals. I'm sure I spelled it wrong. Now, when I say a radical, we are talking about a square root. So when we're talking about the square root, there are certain numbers that we have to constantly be thinking about. You can only simplify perfect squares. You can only take the square root of a perfect square. Otherwise, you end up with an irrational number, which is just a crazy repeating decimal. There are going to be times in life when we use a crazy repeating decimal, but then a lot of times we just want to keep our squares or our square roots in a if you get an irrational number, we're just going to leave it as a square root. So here we go. We have to first constantly remember that 1 squared is 1, which doesn't help us a whole lot here. 2 squared is 4. That's very important. 3 squared is 9. 4 squared is 16. 5 squared is, well, I can think, 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. And I'll stop there, but obviously 10 squared, 11 squared, all of those you should know. We want to make sure that we are constantly thinking about these particular numbers when we're taking the square root of a number. Now, if we have the square root of 25, that is equal to 5. But if we have the square root of 50, a lot of times we want to say that the square root of 50 is equal to 25. The square root of 50 is not equal to 25. The square root of 50 is divisible by a perfect square, but it is not a perfect square. You can't just divide that number by 2. Taking the square root is not just dividing the number by 2. What the first question you're always going to ask yourself when you're trying to simplify a radical is it divisible by one of these numbers? Obviously 50 is divisible by 25. I always put that first. 25 times 2. If we separate this into the square root of 25 times the square root of 2, then that allows us to take the square root of 25 and take the square root of 2, and we can take the square root of 25 and get 5 square root of 2. This is our simplified radical, or our simplified square root for the square root of 50. You cannot take the square root of 2 without getting a crazy long decimal, so there's nothing we can really do there. Now, there are some of you who really seem to struggle with square roots, and so we're going to look at this another way. If your only option for taking the square root of 50 is to do the whole prime factorization thing, then we're going to go with it. Some of you would say this is 5 times 10, and then 10 is 2 times 5. Well, if you list those factors, you want to put the ones together. That means you've got 5 times 5 times 2. And these two 5's have a pair. There are 2 5's under the radical. In order to take the square root, you have to have 2 of the same numbers. So if you take the square root of 5 times 5, it's just going to be 5. And you only have 1 2, so you have to leave the square root of 2. You can't bring that 2 out from under the radical because there's only one of them. Hopefully one of these ways will make sense to you. Tomorrow we're going to look at roots higher than the square root, so it's going to be important that you understand this concept. Let's look at a couple more just to make sure that we're on the right track for tomorrow in class. What if I give you the square root of 120? Well, I know, just from being a math nerd, that it is divisible by 2 because it's even. And so that kind of leads me to check to see if it's divisible by 4. 4 is one of my major numbers. Remember, the 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. Those are good places to start. Start with those numbers. So in my method, I'm going to divide 120 by 4, and that's going to give me 4 times 30. Now, if I think about 30, the only two factors of 30 are 5 and 6, and neither of those are perfect squares. So we really can stop at that point. 4 is the only perfect square that divides into the 120. And so I can take the square root of the 4 and the square root of the 30. The square root of 4 does simplify to 2. And then I can't do anything with the square root of 30. Once we get to over half, then it doesn't matter. And 30 is not divisible by 4, 30 is not divisible by 9, and 30 is not divisible by 16. So we're good. I'm going to have to stop at 2 times the square root of 30. Now, for those of you who are prime factorization candidates, you may do that it's 2 times 60. 60 is 2 times 30. And 30 is 5 times 6. However you break that down, what you would have under your radical is 2 times 2 times 5 times 6. You have to do the prime factorization. This is what you're left with. And so the only doubled up, the only one that I have 2 of is the number 2. So that 2 is going to come out. And then the 5 times 6 stays under there as a square root of 30. So either of these are ways to look at factoring or simplifying a radical. Let's try the square root of 80. If I have the square root of 80, my first method for me is I know that sucker's divisible by 4. I'm sure of it. So if I divide it by 4, then I get 4 times 20. Well, in this case, 20 is divisible by 4. So that's going to give me that whole 4 times 4 times 5. It's not a mistake, but what I didn't see in the first place is that 80 is actually divisible by 16. 16 times 5 is those are my factors of 80. So the reason I started with 4 is because I knew 4 went into 80. But once I divided by 4 one more time, I can see that 20 is still divisible by a perfect square. So I have to take that other 4 out. Well, since I have 2 under here, then that is going to give me 4 on the outside and the square root of 5. If I want to find my prime factorization of 80, I know 2 goes in there 40 times, 2 goes in there 20 times, 2 goes in there 10 times, and then 2 goes in there 5 times. So here's my prime factorization. In this case, I have 2 times 2 times 2 times 2 times 5. I have 2 pairs that I can take out. 1, 2, and another 2. So that's actually 2 times 2 coming out and the square root of 5. And that's another way that you can get 4 square root of 5. Now, tomorrow we're going to look at some situations where we have variables involved as well. So I want to touch base on that. If I want to take the square root of x squared, that just means that I have x times x. And just like when I had the square root of 2 times 2, my answer was 2. Well, the square root of x times x is just going to be equal to x. If I have the square root of x to the fourth, then that means I have 1, 2, 3, 4 x's under my radical. And that will give me 1 x to pull out and 2 x to pull out. So that leaves me with x squared, actually, is my answer for the square root of x to the fourth. But there's a possibility if I want to take the square root of x to the fifth. If I want the square root of x to the fifth, well, I have 1, 2, 3, 4, 5 x's now. So I don't have an even number. It's not divisible by 2. So what happens is I can take out 1x and 2x. I can bring out that x squared. But this fifth x actually has to stay under the radical. There's nothing I can do with that. If I look at an example of the square root of x to the third, y to the seventh, I know that I have 3 x's, so I can take 1x out, because if I were to write this out, 1, 2, 3, I have 1 pair, and 1x is going to stay under the radical, and I have 7 y's, 1, 2, 3, 4, 5, 6, 7, so 1, 2, 3 pairs, so that would be y to the third, and then because it's odd again, I have 1 y left under the radical. You had a video last night. This one lasted 12 minutes, so I'm being nicer. I hope you have a good evening. I'll see you in class tomorrow.